Hello everyone. This video is on the Knewton Alta assignment for section 3.2 part 1 called percent problems and percent increase and decrease. Alright, so in this video I'm going to be going over a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself, but all the objectives are the same, the structure is similar, so I'm hoping that watching me do these here helps you in some way when you work on the assignment on your own. Alright, so on your assignment page should be seeing the title, the mastery bar, right, telling you how far along you've gotten. See your objectives. Looks like there are 3 objectives for this assignment. Under the current objective, there is a question related to that objective, and at the bottom of every question you'll see a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button. Alright, this is for instructors only. But you will have the more instruction button. So if you're ever struggling with a topic, click on this and you'll be taken to a page with further reading or videos to study, and then you'll be given questions related to that instruction, and completing those questions can progress you through the assignment as well. Alright, so the first objective I'm looking at is find percent increase or percent decrease. Alright, so I want to go into those, how to calculate that first, and then we'll come back to this question. So really I'm just going to talk about here percent change. By what percentage of the original amount, did the original amount change? So change could be an increase or a decrease, depending on the values we calculate. Now, one thing I want to recall, hopefully you recall from previous studies, when you see the word percent, that means divided by 100. Per usually implies division, and cent means 100, right? Century, or 1 cent is 100th of a dollar, right? So this means divided by 100. Right? Or when you see the percent symbol, right? That's the percent symbol. That means divided by 100. Okay. So to calculate, by what percentage did some amount change, you do the following. You take the original amount and subtract the new amount, the amount it changed to, and then you ask yourself, what percentage is this of the original amount? So then we divide by the original amount. So original minus new, that whole quantity divided by the original. And then to change this value into a percentage, we multiply by 100, but then throw the percent symbol after this to also say we divide by 100. That way we have the same value. Right? If you multiply by 100 and then divide by 100, it's just like you're multiplying by 1. Yeah, so I take whatever this value is, move the decimal place to the right 2 places, right, multiply by 100, and then call it a percentage, right, say percent afterwards. Now, if this, if this value, if the original amount is bigger than the new amount, then you have a decrease, right? And if the original amount is smaller than the new amount, then you have an increase. Right? Yeah. In fact, you could switch this up as well, as long as you understand, was there an increase or a decrease? Because we're not going to worry so much about the signs. So I could also do new minus original divided by original. Again, you're always dividing by the original. You want to talk about what percentage of the original amount was something increased or decreased. And then times 100, and then percent after. And very often, sorry about the number of formulas here, but they're basically the same thing. But very often, some texts will throw an absolute value around this. New minus original, or original minus new, then divided by the original. All right, the reason they throw the absolute value around is just to make it positive when you're done subtracting. Because again, we're not going to be focused so much on is it plus, is it minus, is it positive, is it negative. You just have to remember, if the new amount is greater than the original amount, you have a percent increase of the original. And if the new amount is less than the original amount, you have a percent decrease from the original. And again, times 100 and then divided by 100, but throw the percent symbol after it. So yeah, but either way you're doing this, no matter how you cut it, you're taking the difference between the original and new amounts and then dividing by the original amount. So no matter how you cut this, that's what you're doing. Right? And then changing it to a percentage by multiplying by 100. Right? So back in this question here, an employee receives a pay increase, so they're telling you it's an increase, right? From 35,000 per year to 37,500 per year. Calculate the percent increase and round to the nearest tenth of a percent. All right, so I'll put this up so you can still see the problem. All right, then on a new sheet of paper, and the percent increase, right? It's just percent change, but they told us it was an increase. Is the following. Now, like I said on the previous page, you can do it in either order, right? Or do absolute value of the difference. But personally, I like to take the difference so that you have a positive amount in the numerator, right? And just understand that it is an increase, right? Because you're going from 35,000, right? That's the original amount, to $37,500 a year. That's the new amount, right? So just so you understand that it is indeed an increase, right? This should be a percent increase. If I went to a smaller value, then I would do the same calculations, but remember that it's a percent decrease. So I take, again, I like to take basically the numerator is just what's the difference. And I like to take the difference so that it's a positive value. So $37,500 minus $35,000. Right. That's going to be the numerator. But then remember, we're saying what percentage of the original amount is this. So the denominator on all these, no matter what formula you decide, what version of the formula you decide to use, the denominator is the original amount, that 35,000. Right. And then again, we're going to take this value, whatever it is, and then multiply it by 100 and throw the percent symbol after it. All right, so 37. All right, so let me go make this paper bigger here. So 37,500 minus 35,000. That's 2,500. That's the difference between those two values. And then what percentage of this, of the original amount is this? Dividing this by 35,000. And again, we'll say times 100 and then throw a percent after it. Okay, so when I divide here, I can get rid of these two zeros, right? They have a common factor of 100. They even have a common factor of 25. 25 goes into 25 once, and 25 goes into 300. It goes into 100 4 times, so 312 times, and then 2 more for the 50, so this is 1/14. Alright, and if I divide 1 by 14 on a calculator, so I'm just doing this off to the side in my hand calculator, 1/14 or 25 divided by 350, same thing, is equal to 0.07142857, and then this 142857 repeats. A little vinculum bar above that, 142857, 142857, 142857, and so on. So that's this number in the parentheses, and then again we change this to a percentage, multiply by 100, right, and then throw the word percent, throw the percent symbol at it, multiply by 100 and then divide by 100. So if I multiply by 100, this is 7.142857 repeating, and then percent, right? Throw the percent symbol at it. That would divide you by 100 and move it right back. But multiplying by 100 moves the decimal place to the right 2, and then the percent symbol would move it right back, right? So you get the same value. Now they did ask us to round to the nearest tenth of a percent, right? So 1 decimal place. So instead of 7.14 blah blah blah, that would round to 7.1%, right? This is approximately 7.1%, and that's what they want from us, right? So there was about 7.1% increase in salary, right? He was getting paid $35,000 a year originally. That got bumped up by $2,500, and $2,500 is about 7.1% of the original $3,500, so there was a 7.1% increase. And that's what I'm entering here. See, they got the percent symbol already. Right, so I'm just putting the percentage rounded to the nearest tenth. Now, after you submit an answer, it'll tell you if you got something correct or incorrect, and then it'll go over some sort of answer explanation. Okay, say I see new amount minus old amount for increase, and I'm going to guess they do it the other way around for a decrease, right, just so that the difference remains positive. And they write out these words here. This is what percent. Basically, again, you're just dividing by the original amount. All right. We'll talk about word problems, that are written out in percentages later in other objectives. All right. But please read through the answer explanations, though. Make sure you understand why something was correct or incorrect, and hopefully you can learn from your mistakes for future questions. Alright, next. Alright, so now we're on this objective. Solve basic applications of percent. Alright, so remember, the word percent, when you see the percent symbol, or the word percent, that means divided by 100, if you want to write it that way. So here we have after 3 months on a diet, Lisa had lost 12% of her original weight. So she lost 21 pounds. What was Lisa's original weight? Alright, so just like any other word problem, right, I've read through this, and then I ask myself, I identify unknowns. What's unknown? What do they want from me? What are they asking for? Right. And that was Lisa's original weight. So I'll write that out, right? Lisa's original weight. And this is unknown, I've identified what they wanted. And then you name that thing, right? Just so I don't have to keep writing out the words Lisa's original weight, right? That would be tedious after a while. So I could call it L for Lisa or W for weight. I'll use W for weight, or you could just call it X or Y or Z, whatever you want. Now, they do mention, right, that Lisa had lost 12% of her original weight. So 12% of original weight is the weight that was lost. And they said that that she lost 21 pounds. Right, so 12% of the original weight is 21 pounds. And I can translate that now into an equation. Now 12%, you can write 0.12 or 12 divided by 100, which I like doing myself. This is the same thing as 12 and then percent. All right, 12 divided by 100. Remember of usually represented multiplication. All right, so I got a little dot here for times. And then Lisa's original weight, remember I'm calling that W. And then is the verb, equals, right, is equals. And then the other side is just the 21 pounds. And then I have a very simple equation. You translate into an equation, remembering that percent means divided by 100. That really helps a lot. Or you could change it to a decimal by dividing by 100 and writing this as 0.12. It doesn't matter to me. And then I have an equation to solve, right? You solve this equation for W, and then use the solutions of your equations to answer the question. So this 12 100ths times W equals 21. I could simplify this fraction. 4 goes into 12 3 times. 4 goes into 100 25 times. So 12 hundredths, 12% is the same thing as 3 25ths when you reduce completely. And this is equal to 21. And remember how to get rid of fractions, right? I want W alone. You can divide by 3 25ths or multiply by 25 thirds, right? Remember, division is the same as multiplication by the reciprocal. Right? So multiply both sides by 25 thirds, and then we'll have solved for W. Now 3 goes into 21 7 times, and 7 times 25 is 175, right? 140 plus 35. And there's W, right? And that represented Lisa's original weight. So, and then the units on this was in pounds, right? LBS. And there you go. That's the answer to our question, right? Lisa's original weight was 175 pounds, right? Because 12% of that is 21 pounds, right? If you were to take 175 and multiply it by 12% or 0.12, you'd get 21, and you can double check that. Yeah, so 175 pounds was the original weight. All right, and again, now you see they use 0.12 for 12%. I used 12 divided by 100, the fraction. It depends really on what you like working with better. Do you like working with decimals or fractions? I personally like working with fractions more than decimals. It doesn't matter though. All right, next question. All right, so we're still in this objective, solve basic applications of percent. All right, so once again, I'll make sure that you can see the problem here. Bring out a piece of paper. All right, so this time we have Tim. Tim left a $9 tip for a $50 restaurant bill. So what percent tip did he leave? All right. So basically, the question is, $9 is, and this is probably the hardest part, and this is always the hardest part in a word problem, translating the English into math. We can write this another way though, saying that $9 is what percent of 50? That's really the question being asked here. $9 is what percent of $50? Right. Because the $50, you left a $9 tip, and they're asking what percent was that tip. Right. Now $9, that's just, I'll write 9 on the left side, is equals what percent? So when I see what, that's going to be some unknown, right? I'll call that X. Percent, remember percent, I like to think of, and what it means is divided by 100. So here's what percent of times, and then $50, right? 50. And then over here we can do some easy simplification, right? 50 goes into 100 twice. So really what we have now is 9 equals X divided by 2. And all I would need to do to solve for X here is multiply by 2. X equals 18. So replacing the word what with 18. $9 is 18% of 50. So he left an 18% tip. That was an 18% tip, and that's the answer to our question. All right. Now they already have the percent symbol there. I just need to write the 18. All right. All right. Next question. All right, so back to the find percent increase or percent decrease. So remember, it's just what's the difference in the values, and then divide that by the original value, right, the original amount. What percentage of the original amount was that? So here, according to Time magazine, the annual global seafood consumption rose from 22 pounds per person in the 1960s to 38 pounds per person in 2011. So there is an increase, and they're asking us to find that percent increase and round your answer to the nearest tenth of a percent. Alright, so I'm not going to put the problem up. I'll just write out what happened here. Alright, I said it went from 22 pounds per person up to an increase to 38 pounds per person. So we have the original amount, right, was 22. The new amount is 38. So the percent increase, right, the percent increase is just what was the difference in these, right? 38 minus 22, and they're asking, well, what percent of the original amount is that? All right, divide by 22. And then of course we're going to take this value and change it to a percentage, right? Multiply by 100 and then divide by 100, right? Throw the percent symbol after. All right, well, 38 minus 22 is 16. All right, so this is 16 20-seconds, and then, times 100, and we're going to put the percent symbol after. Now, if you want to, now you can put this in your calculator if you want, that's fine, but this reduces to 8/11ths, right? This is 2 times 8. This is 2 times 11. 8/11ths, and then change to a percentage. Now, 8/11ths is 0.72 repeating. It's 727272. I'm pretty sure. Let me just make sure, double check with my calculator off to the side here. 8 divided by 11, yeah, it's 72 repeating. Which, if I change this to a percentage, this will be 72.72 repeating percent. Right, I multiply by 100 and then throw a percent on to divide by 100. That way I get the same value. And we're asked to round to the nearest tenth of a percent, which would be 72.7. So that's a huge increase, right? A change of 16. 16 is 72.7% of the original amount, is 72.7% of 22. So you have a 72.7% increase in annual seafood consumption, right? According to Time magazine. And they already have the percent symbol there, so I'm just putting the number 72.7. And there we go. All right. Next. Alright, so we haven't seen this one yet, but I've kind of been talking about it, like, I've done this in another problem previously. Translate and solve basic percent equations. So here's one where they kind of give you a nice sentence that you can pretty easily translate to an equation. Alright, so I'll make sure you can still read that. Right, new piece of paper. So, what number, I'm going to call that n for number. What number? I don't know. I'll call it n. Is equals 66%. You can put 0.66 if you want. That's 66%. Or 66 divided by 100. Same thing. Of times, and then 1,155. Maybe I'll do this here. So, but you're just doing this. This is what number n is equals 66% of 1,155, and then just multiplying these. And again, I'll do this on a calculator. They ask us to round to the nearest tenth. N is already alone here, and I'll put approximately equals, and I'm just going to a calculator for this. So if you have one, use it, right? So 0.66 times 1,155, and actually there's no approximation here. This is equal to exactly 762.3, as it doesn't go on any further. This is it. So it's not approximately equal to, it actually is equal to this. 762.3 is 66% of 1,155, and that's what I shall enter. 762.3. Right. Oh yeah, and they had n equals, so they used n for number. Great. I'm hoping the translation is simple enough. Just remember your key words, and that percent means divided by 100. Alright, so another one of these. So 344%, which I could write 3.44 or 344 divided by 100. Same thing. Of what number is 34,400? So once again, make sure you can see the problem. All right, so I'm just going to do this on the bottom half of this page. So 344%. So you can write it like this, 344 divided by 100 or 3.44. Same thing. Of what number? So times n, or x, or z, or whatever you want to call it, is equals, and then 34,400. Well, to get n alone here, just need to multiply both sides by 100 over 344. Or divide both sides by 3.44 if you wrote it as a decimal. Now, I'm hoping it's obvious here, but 344, here you got 344, times 100. This will go into the 34,400 100 times, and then 100 times 100 is, 10,000. So n is 10,000. The number they're talking about is 10,000. And that's what I'll enter. They said just put the answer, just the number, right? What number are they talking about? 10,000. Okay, great. Next. All right, so another one of these. Again, something where it should be pretty simple to translate. So back to where you can hopefully see the sentence, and we'll just make an equation out of it. So it starts off with 3,984 is what percent? So like I did earlier, what is x? Percent is divided by 100. There's what percent of 24.9. Right, times 24.9. And then I solve for x. So x is going to be equal to, all I would be doing is multiplying by 100 and dividing by 24.9. So this is going to be 3,984, times 100. Put 2 zeros on that, and then divide by 24.9. And I'm just going to use a calculator here. Right, so again, off of my hand, off to the side. 3,98400 divided by 24.9 is 16,000 even. How nice. And there's the number in question. X is that. So this is 16,000%. So if I replace the words, right, that means 3,984 is, 16,000, and then the word percent I can write the symbol for. Percent of 24.9. Basically, 24.9 times 160 would be 3,984. And you can double check that with a calculator, or whatever, do it by hand. 24.9 times 160 is 3,984. So 16,000% is what I'm entering back in the assignment. Great. Alright, they use P instead of X. Whatever. Now they didn't use the percent part, they just called what percent P for percent. divided by 24.9, got 160, but then you got to change it back to a percentage, though. You got to change it to a percentage. 160 is 116,000%. All right. Remember to change a number to a percentage, you multiply by 100 basically, and then throw the percent sign after. All right. And then here, one more of these. What number, so I'll call it X or N or whatever, is 344% of 107? Well, this would just be N equals 3.44 times 107. So I'm just going to do that on my calculator. 3.44 times 107, and I get N. And it says round to the nearest hundredth, but it just goes to the hundredths. It's 368.08. That's 3.44, 344% times 107. All right. Okay. All right. Next, back to the solve basic applications of percent. So again, I think the hardest part, as with most word problems, is going to be to translate into an equation. Alright, so here 1 serving of trail mix has 67 grams of carbohydrates, which is 22% of the recommended daily amount. So what is that recommended daily amount? Round to the nearest gram, right? The nearest whole number. Here, the nearest whole gram. Alright, so I'll just pull out some paper. So they're saying to us that the 67 grams is 22% of the recommended daily amount, which I don't know. And I'm going to call X the recommended daily amount. So yeah, 67 grams of carbohydrates is 22% of the recommended daily amount. And then I just simply divide by 0.22. 67 divided by 0.22. And they're asking us to round this to the nearest gram, the nearest whole number here. Again, I just off to the side, I've got a calculator on me. So 67 divided by 0.22 is 304.5, so that would round up to 305 grams. This is the recommended daily amount of carbohydrates, 305 grams approximately. That's what I'm putting in here. Now they have the word grams already. Right? You don't have to type the units. All right, great. All right, next. So one more of these basic applications of percent. So here, so it's another kind of sodium deal. It's like the carbohydrates, but this time with sodium and milligrams instead of grams. So a grilled chicken salad at a popular fast food restaurant contains 650 milligrams of sodium. This 650 milligrams is 27% of the recommended daily amount. So what is the recommended daily amount of sodium round to the nearest milligram? So it's very similar to the previous problem. The 650 milligrams is 27%, so 0.27, times the, again, I'll just say X is the recommended daily amount again. So X is going to be 650 divided by 0.27. And remember, X is in milligrams, so I'm just going to round this to the nearest milligram, the nearest whole number. Again, off to the side, I got a calculator on me. 650 divided by 0.27 is 2,407.4. So that would round down to 2,407, the nearest whole number. So about 2,407 milligrams. This is the recommended daily amount of sodium. and that's what I'll be entering in the assignment here, 2,407. Great. All right, then we should be having just a couple more of those percent increase, percent decrease problems. All right. So for the first year of his car insurance policy, Tom pays $77 a month. Tom's payments are reduced to, now this is a percent decrease, right? It went from 77 to 65. In the second year, as a reward for good driving, to $65 a month, right? What is the percent decrease? Rounded to the nearest tenth of a percent. So again, remember, I'm going from the original amount to the new amount. The percent decrease is a percentage of the original amount. So it's what's the change? 77 minus 65 is 12. That's the, just put the difference up top, divided by 77, and then we're going to change that to a percentage after. Now 12 divided by 77, this is 0.1558 and stuff. But when I change it to a percentage, this would be 15.58 and so on percent, which if they're asking me to round to the nearest tenth of a percent again, this would be about 15.6%. So there's a 15.6% decrease from the original amount. So that's all I'm putting here, 15.6. Right. But yeah, percent increase, percent decrease, easy enough, right? Just what's the change? What's the difference in the new amount between the new amount and old amount? And then divide that by the old amount, the original amount. What percentage of the original amount is that? And of course, change the final value to a percentage. All right, so I got one more of these. All right, so again, a percent decrease. In 1 month, the median home price in the West fell from $203,400 to $192,300. Find the percent decrease and round to the nearest tenth of a percent again. All right, so back on the paper, went from $203,400. Make sure you're copying things correctly. Went down to $192,300. The percent decrease from the original amount would be the following. Well, what's the difference here? The difference would be $11,100. If you subtract these, and then divide this by the original amount, $203,400, and change this to a percentage, right? So again, I got a calculator in my hand. 11,100 divided by 203,400 is about 0.0545 and so on. But when I change this to a percentage, this would be, move the times 100, you get 5.45 blah blah blah, and then throw a percent symbol after to divide by 100, give you the same value. So, and then if I round this to the nearest tenth of a percent, like they're asking again, 5.45 would round up to 5.5. So this is about a 5.5% decrease from the original amount. And submit, and hopefully that's good. I didn't do my difference wrong. All right, great. So yeah, the same procedure, same setup for all these percent increase, percent decrease problems. All right, and that's it. That should be it for this preview version. Now, like I said at the top of the video, the questions I saw here may not be the same as the questions you see when you work on the assignment yourself. But the objectives are the same. and the structure is the same, structure is similar. So I'm hoping that watching me do these here helps you in some way when you're working on the assignment yourself. And thank you very much for watching.